205. There we go. So, welcome back. If you don't know who I am, I'm Eli, the computer guy. I've been doing tech education since 2009. I've been doing tech since the 1990s. Done a whole bunch of different things. Anyways, basically the idea with Silicon Dojo, what you're currently doing right now, is what if technology education was authorityless, gatekeeperless, free to the end user, hands-on, that empowered you to do whatever the hell it is that you want to do. And that's basically what we're trying to do here. Again, this is the online component, so you can attend this from Brazil or wherever you're at. We do have the in-person component, again, in Asheville, North Carolina. Next week we are starting our first class, and then in Raleigh, North Carolina, we will be starting classes, I don't know, once we get to it sometime in next year. Again, this is free to the end user. Basically what that means is we are crowdfunded, so people that find this valuable and have some extra money to throw at it, they throw money at it. If we get enough of those people doing it, I don't know, maybe I can feed my dog. Hopefully we get a decent amount of money. There is a donor box link somewhere around, and basically, again, $5, $10 a month. If you throw that in there, that would be great. $1 once, that's also fine, but basically that helps pay for everything. We do have, again, our online stuff. So Silicon Dojo, so this is silicondojo.com. This is now live and active as a couple of days ago. Basically on here, this is just going to be the central repository for information, for class schedules and that kind of stuff. So that is there. And again, we have our nice donor box link up above if you would like to throw a couple of dollars in. Beyond that, GitHub. So this is where we store all of our documentation currently. So all of these classes basically not only are free for you to use, but also if you want to use them for commercial purposes. If you want to create a school in Mogadishu and teach people Linux, you can take all the material that I've created and teach people Linux and charge them whatever you want to charge them. So all of that material is here. It's GitHub, Silicon Dojo, online classes, and then you get this mess. Again, as we go, we will try to clean this mess up because it is a bit of a mess. These classes are being recorded. So this camera right here, this is going into Zoom, where you get a very crappy bitrate of 1080p. I don't understand. Anyways, their quality of video is very bad. Literally right beside it is a 4K camera, and so that 4K camera is recording this entire session. So if you want to watch this session afterwards, or if you miss a class, at least the online classes, there is going to be a 4K version. Generally they're uploaded either the night of the class or many times the day after the class, relatively soon after the class. The good part about that is it is 4K, so you can zoom in and you can see different things that you care about. If you want to follow me on LinkedIn. Oh, there we go. I got a LinkedIn account here. If LinkedIn will show it to you. Again, you can go to Eli the Computer Guy. I post stuff here. If you won't care, go there. Again, we have the meetups. So with the meetups, we have 3 meetups. We have the online version, we have the Asheville version, and we have the Research Triangle version. If you want to go and search on Meetup for these and join any one of them, that is great. And I think that's about all we got for today. I guess we gotta get in the class. No, I don't want to teach. Mama, teaching technology is so hard. Anyways, we're going to be teaching Linux today. Linux is very important, especially if you're going to be dealing with many of the projects that we're going to be dealing with here in Silicon Dojo, because again, one of the things that you have to think about whenever you're being taught by somebody is to think about what their bias is, where does their mind go, what are they trying to accomplish, what is their intent. Are they a literary arts, professor that now has to teach you PowerPoint, and so their only goal is to get the hell out of class? Or do they actually care about technology? Again, so for me, I actually do care about technology. Again, doing technology since '96, MCSE in 2000. And what I really like are systems. I think systems are sexy. So we talk about systems in the modern world. We talk about things like IoT, Internet of Things devices. We talk about robots. We talk about the AI stuff. And basically, whenever we're building these systems, we need to interact with what is called the full stack. So you'll hear about different types of developers. You'll hear of front-end developers. You'll hear of back-end developers. You'll hear of database administrators, the whole 9 yards. And then there is the full stack developer. Basically, the idea with the full stack developer is that you can actually go and deploy something. Again, this is what we all used to be. Back when I started in the technology, you were just told to go and make it work. You just had to figure the crap out, right? Not so anymore. Again, it's amazing how many people are now JavaScript developers and things, and literally have no idea how the back end works. Ooh, I got lots of markers. So anyways, why this is important, when we start talking about our stack, we got a stack around here. Let's do it in red, right? And so when we start creating these apps, again, service-oriented architecture, all these things that we talked about, right? So, you know, we're gonna hit the cloud, right? And over here, we're gonna interact with Twilio as an API call. We're gonna deal with OpenAI, AI services and AI call. We're gonna do all that kind of stuff, right? But the thing is, and then we're gonna have our box, right? And on our box, we're gonna have a web app framework. We use Bottle. It's a micro framework. Because, again, my bias is dirt simple. I want you to be able to deploy as quickly as possible. So Bottle is not the greatest web app framework out there, but it does a good job, right? Anyways, then under that, basically Bottle uses Python, so that is part of the stack. These are going to be communicating with some kind of SQL server. So again, we do simple here, so we use something called SQLite as our SQL server in general. And then under this, right, then this is all going to be a box somewhere. We've got the operating system underneath, and that is going to be Linux. So Linux is the operating system. And the cool thing is once you can get Python to start communicating with the operating system, you can do a lot of fancy, cool things. Because again, one of the problems with new people want to reinvent the damn wheel. Do you know how many 18-year-olds I've heard back when web app development or web design was a much bigger deal? And they were like, Eli, I would never buy a template from a template site. I will only ever hand the code my CSS. You're just like, why? Why? You're gonna spend 3 weeks to hand code something you could literally spend $25 to get a template for? That doesn't make a damn bit of sense. But anyways, we get a lot of that with the news, right? I'm gonna hand code. Okay. Just don't do it on my dime. Don't do it on my dime. But the cool part is, right, once you can interact with the Linux operating system, you get all the power of Linux. You get all the power of an operating system, basically just a Python command away. So everything from ping to nmap to FTP, file transfer services, all kinds of amazing things, right? You get all the power of that if you understand how Linux works. And the other thing, too, is that Linux is actually what all of this crap is going to be running on. So basically, you have to understand Linux just to understand basic administrative tasks. So it's one of those things like you gotta learn Linux. It's not 2000. Here's the deal, boys and girls. I was there in 2000. I was there when you can make a lot of money and not know Linux. That was 24 years ago. You gotta learn Linux, at least to some degree. But don't worry, it's really not that hard. One of the big things, again, my little buzzwords that I say, right? AI is hard, APIs are not. One of the big things to remember, being a technology professional, is that you do not have to be smart. It is incorrect to say that you have to be smart. You have to be precise. If you know the commands to run, and you're precise about actually typing the damn things in, you're going to do fine. You don't have to be brilliant. The issue that we get into with the Linux world is, there's nothing quite like having a command line cursor blinking at you for the first time, and you have literally no idea what the hell to do next. You're like, oh my god, you must have to be smart to be able to deal with this operating system. It's like, no, you don't have to be smart, you just have to know what to plug in. Anyways, that's the kind of stuff that we're going to be talking about today. So when we talk about Linux, what is Linux to begin with? First, is Linux Unix? No, Linux is not Unix. It is not. It's something called Unix-like, and we'll talk about that. All right, so basically what Unix was, I guess it's still around, is basically there's a proprietary operating system, I do believe by Bell Labs, that was used to drive big crap. So if you think about the entire telephone system, right, switchboard operator type of deal, that's what Unix was used for. Literally launching things like nuclear weapons and really complicated computer stuff That's what Unix was used for. It was proprietary. Basically, you did have to pay for it. You had to pay a lot of money for it. And so most people didn't use it. Kind of like, think about that with IBM mainframes nowadays. I have a buddy of mine who's very successful in IBM mainframes. And one of the things I always think is funny is they need people to do COBOL and mainframe work. But mainframes are such this huge, expensive, weird thing that there's no real easy way for a noob to learn how to interact with mainframes and then get ahead, right? How do you get your hands on a mainframe, right? And so basically that was one of the big problems back in the day. Is again, if you wanted to be a Unix administrator or something, you basically have to go off, get your comp sci degree, get a degree so you could be around these multi-million-dollar boxes and do what you do back in the day. Then you had GNU. So GNU came along, I think it was in the 1980s. There was this guy called Richard Stallman. I'll let you all figure that out. He's either canceled or not canceled, or he got uncanceled. That's its own stupidity. Anyways, there's this guy called Richard Stallman, Free Software Foundation. And basically what he was looking at is that Unix was so powerful. He worked for MIT, he was a professor at MIT. So powerful, so useful, the whole 9 yards. And basically this is kind of where the open source really started from. As he said, what if those tools were available for everybody to use? What if anybody could use the ping command? And again, it's the 1980s. That's actually a big damn deal back in the day. Anyways, so Richard Stallman came up with GNU, and GNU means GNU, not Unix, because that's MIT humor from the 1980s. But the important thing to understand with GNU is it was only tools. It was this really weird thing. And again, it's something to think about with how technology actually develops, is they created these Unix-like tools, but didn't actually have anything to run it on. Like the last thing that they got was the kernel itself. Christopher is saying inappropriate things. Donna is talking smack about Eli Guy. What is going on? Okay. Stop your video. Oh, hacker. Oh, look at that. People are hacking my stuff. Anita is trouble. I say we eject Donna. Fuck. Yeah, that's the thing whenever you get hackers or whatever. Anyways, okay. Host tools, chat. Chat goes away for a while. Hey, dear hackers, you're right. I don't have the bandwidth to be able to deal with you. So we turn off chat. So that's basically what's going on. If they do something in the video stream, I highly apologize. I'm trying to teach a damn class, so I can't keep up with it. So I don't know. Turn off the... Don't watch the other people if they start doing stupid things. Again, it is an interesting thing in the modern world. You actually try to do something good for the planet. You try to do something good, you make something freely available, you make it accessible, you put all the time and energy and everything into it, and then jackasses are going to be jackasses. What are you going to do? Anyways, you're going to move the fuck on, right? All the world cares about is that you move the ball forward. You can be screaming about the jackasses as you move the ball forward. You can be crying about the jackasses as you move the ball forward. The only thing that matters is that you move the ball forward. So anyways. So GNU. So they came up with all these utilities. Again, how people do things in the tech world. They didn't really actually come around with like the kernel, like the thing to make all of this stuff work as an operating system, and so they're kind of stuck. That's where you get Linus Torvalds, 92, I don't know, somewhere in the early 90s. He's going through, he's doing his projects, and he comes up with what's called the Linux kernel. And so the kernel of the operating system is basically what allows the operating system, what allows the software to talk to the hardware, right? RAM, hard drives, right, basically the hardware, you got the software, you got that little OS kernel in between. And so, you know, Stallman and Linus Torvalds, I don't know if they like each other or not, but they come together to create what is called GNU Linux, GNU Linux. So it's the GNU tools, the Unix-like tools on the Linux kernel creates the operating system, more or less. that we use today. So you will hear, again, some of the 18-year-olds out there going, I only call it GNU Linux. It is great. You call it whatever you want to call it. I'm too tired. Let me explain it to you. You walk into a server room and you're like, oh, what are you running in here? And they're like, oh yeah, so that's our rack of Linux boxes and that's our rack of Active Directory. And then you walk over to Linux boxes. You go, huh, Linux. What flavor of Linux are you running? It's like, oh, we got 5 Ubuntu servers there, and we got a CentOS, and then we got a couple of Red Hat down at the bottom because we're doing something enterprise level. We need the Red Hat. And that's how actual professionals talk. If you hear people talking about GNU Linux, keep on moving. Keep on moving. So anyways, that's where we get to with GNU Linux. Then we get to forks and distros. So one of the interesting things when you start dealing with Linux, one of the big pains in the asses for Linux is, again, there's an interesting question, right? Again, I call it the thing of the name. When you put a name on something, what is actually that thing? And so many of us, when we think operating system, what does that conjure in your mind when you think of an operating system? Again, so I came from the Windows world. Before I dealt with Linux, made money dealing with Windows because Linux didn't matter in the day. Anyways, Linux came in, had to learn Linux. So I think about like Linux server the way I think about Windows Server. And so with Windows Server, right, you install it and you get Active Directory and you get file sharing and you get print sharing and you get route and remote access, which is VPN services. You might get SharePoint services. You get IIS, right? When you look at a Windows Server, you install this thing and there's all this stuff. And again, it's basically you just click the box, you change a couple of configurations, and then your box is doing whatever the hell it's supposed to do. Here's the thing in the Linux world, especially being open source, the operating system really is just the operating system. Again, you get that kernel, you get those very basic Unix commands, ping and traceroute and LSL and that kind of stuff. And then everything else is basically whatever the person who developed that fork or that distro decides to put on there. Again, it is less than amusing when you go from being a Windows administrator to being a Linux administrator, and then you try to figure out how to share files. But mommy, all I want to do is share a file. Great, that's going to take you 2 days to figure out. Anyways, right, because the thing is there's all these different utilities, right? If you want to do FTP, File Transfer Protocol, right? Generally, we've been using VSFTP. VSTPD is the service that I like to use, but there's 20 FTP servers out there. Again, 20 different ways to skin a cat. You want to do FTP? Here's all the ways you can do FTP. You want to do a web server? Here's all the ways you can do a web server. You want to do any of the normal services that you're thinking about? Here's all the different ways that you can do it. In the first place, this gets us into weird things, is forks. So the main forks that you're going to be dealing with are Debian or the Red Hat world. So Debian Linux is either Debian itself, or you're most likely going to be using Ubuntu. So we use Ubuntu at Silicon Dojo, and Ubuntu is just the good go-to one, right? It's very popular. It's relatively easy to use as far as Linux is concerned. And again, it's kind of like one of those weird standardized things. Everybody has their own favorite. Use what you want to use, but here we standardize on Ubuntu, and that's part of Debian. There's Ubuntu, there's Kubuntu, there's a whole bunch of Ubuntus. Is Arch, Mint? I don't know, there might be different forks at this point in time. Anyways, there's a whole bunch under Debian. Then you have the Red Hat, and when you deal with the Red Hat fork, basically you're dealing with Red Hat, CentOS, and Fedora, I think are the main ones on Red Hat. The issue that you get into with the forks, so the fork is a split at the highest level, right? Basically, you got Linux, and then you immediately fork. The issue that you deal with forks is a lot of stuff that you would think would be pretty set and settled is not necessarily set and settled up at the fork. So if you want to install software onto your server, so when we use Ubuntu and we install something onto the server, as I'll show you how to do later, we are going to use apt install. So there's a utility called apt. Used to be called apt-get. Apt-get actually still exists too. But anyways, we use apt, we use install, apt install, blah, right? And that's how you install things. Pretty simple. You go to a Red Hat fork, and it's a yum, Y-U-M, because they have their own way of installing crap. At the end of the day, basically same but different. But the important thing to understand, it's a different command. And so again, one of the big things you need to be thinking about with Linux, especially with your environment, is standardizing as much as possible. Because it's not that Ubuntu is better or worse than Fedora, but when you have a technician or when you are sitting down, how many different types of Linux boxes do you have? You can know what you want to do, but if you sit down in the box and you're not used to the commands for that particular fork, it can be a bit of a disaster. You're like, no, but I know what I want to do. I just don't know the damn command to make it do it. Anyways, frustration, PTSD, tech PTSD. So that's forks. So that's up there at the high level. Then you have distros. And so distros, right? So we go to Debian. All right, so we take a look at that. Oh, right, so, we have Linux, and then that gets forked, right? So one side we have what's called the Red Hat world, one side we have the Debian world, and then under Debian, basically you have the distros, right? And so Ubuntu is a distro, and Kubuntu is a distro, and I don't know, is Mint? I feel like somebody's going to scream at me. I feel like I'm getting nasty grammar. I think Mint is under Debian. There's something called Arch. Is Arch under Debian? I don't know. We'll say these are under Debian. Anyways, basically the idea is that these are distributions of this particular fork. Now, why is that important? So the main underlying software to make the fork go is going to be the same. Apt, and apt, right? Basically systemd, whatever. They're going to be using the same stuff for these. There's just going to be slight changes between these different distributions based off of what are they trying to accomplish, right? So you may have one, I think Mint was the one, you may have one distribution that's trying to mimic Apple, right? We're going to try to compete with Mac OS, and so we're going to try to make this like really fancy and really flashy, just consume a tremendous amount of RAM and other resources to do all this fancy stuff, right? So this is going to compete with modern desktop environments. And then you may have a different version, Mate? Is it Mate? Mate. I think it is, where basically it's small. So there used to actually be a distribution called DSL, I don't know if that's still around, something called Damn Small Linux. And so the idea with Damn Small Linux is basically you have the basic tools under Debian, but you're going to be putting this on a potato, right? You're going to be putting this on, a Raspberry Pi or some incredibly low power, low resource hardware. And so you want only the basic crap that will allow Linux to work. And so that's what that distribution was for. And so that's what you start getting into with these different distributions, is they're literally designed to do different things. Again, is there Edbuntu? There's so many Buntus. I think there's Edbuntu out there, but basically Edbuntu was a Ubuntu, essentially, distribution that was designed specifically to be used in classroom environments. And so basically it's loaded up with a whole bunch of tools that are supposed to be useful for students if you're going to junior high school or high school. And that's all we're talking about when we talk about distributions. So forks are the big deal. I'm going to say it. Pick a fork. Pick a fork. Most likely Debian. Pick the Debian fork. Anyways, under that, distributions, not so big a deal, but you can run into some weird problems. Oh, if you do have questions, dear hacker, I am trying to make the world slightly better. Anyways, if you do have questions, do raise your hand within Zoom so that I can see it, and I will allow you to unmute yourself. And hopefully that won't be a damn disaster. So anyways, so we got the forks, and then we got the distros. Then under this, we have shells. So basically what the shell is this is the user environment that your user is going to be interacting with. So it's going to be like a GUI shell. Like, so this is a shell. Right, this is a shell. I can swipe this way and I can swipe this way, and if I double click something happens, and if I right click something happens, blah, 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 blah. Right? That's all basically a shell is. The thing is, different shells, again, have different resource requirements, right? Animation, right? So if you click on an icon and it does some fancy animation, that takes RAM, that takes resources. right? If you got 32 gigs of RAM and SSDs, you don't care. If you're using a potato, basically if you're using like a Raspberry Pi Zero or something like that, you may not want all those animations, right? So basically there's different shells, and those shells are designed basically for particular environments. So again, which one is it? Which one is it? XFCE. Again, these are all just words. We got a GNOME shell. Ubuntu currently uses GNOME 3, as I understand. We have something called the KDE shell and Plasma. And then there's XFCE shell, and then again, that's the very lightweight shell. And so you choose these shells based off of, again, performance and utility and that type of thing. Again, so that's one of those, you got to figure that kind of stuff out. And then finally, with the different versions of Linux, you're going to see server and desktop. So this is going to be important, especially when you're new to the Linux world, and I'm just going to tell you, install desktop. Just install a desktop. Don't worry about it. You'll learn it. You'll learn it. Just install a desktop right now. So basically, when you go to like Ubuntu and you go to download the ISO to install Linux onto your hardware, there's going to be a server version and desktop version. Basically, the desktop version gives you a graphical user interface. So if you download and install Ubuntu, you're going to get GNOME. I think it's GNOME 3. If you do the server version, you're going to get a command line. Again, and we talk about command line, like this is my server. So I have a DigitalOcean server running, and this is what you get. If you feel comfortable, if you feel comfortable just walking into this particular environment, you go for it. But this is what the server looks like. So you kind of got to know what the hell you're doing before you get to the server environment. The desktop, as I'll show you in a minute, is just a normal desktop environment. And so that's one of the reasons why you should start with the desktop. The benefit to this, incredibly low resource consumption, just for normal stupid tasks. It is more secure, right? The more functionality you have on a server, also the more vulnerabilities you have on a server. So that's why, again, just doing the server thing is better. But, I mean, like I say, you literally have to know the command or it doesn't work. Yeah, let's see here. And with those, again, everything is basically just software in this particular environment. So if you have a desktop and you want to turn it into a server, get rid of the GUI, you can actually remove the GUI component from that to turn it into a command line. More importantly, if you have a server and you want the GUI for whatever reason, let's say you're walking into a legacy environment, this box has already been built, the whole 9 yards, you can add a shell, you can add a graphical user environment later, again, as long as you have enough resources for it. Let's see here. As we go through, I'm not going to go through actually installing Linux server because that's its own Megillah. It's actually very easy to install Linux server or the desktop operating system. It just takes a little bit to do. Basically, what you need to do is you need to go to Ubuntu. So if you go to, let's pull it up here, Ubuntu. If you go to Ubuntu, accept all that, basically you are going to have, where is it? Products. So the desktop, or they have the server, so we can do something like this, the desktop, and you can simply go and literally download Ubuntu desktop. You click on that, yeah, it takes you here. There's different versions out there. So the LTS is the long-term service release. So basically what this means is that this is the version that they expect to last the longest. It's going to have the support for the longest amount of time. So they have like nightly builds, they have newer builds that might have some new functionality to it, but basically you should always do the LTS, and essentially you download the LTS and that gives you something called an ISO file. Now the issue with the ISO file is that's not actually what you need at the end of the day. All right, so you're gonna need a flash drive. You're gonna need a flash drive. I think it has at least 12 gigs of RAM for the flash drive. And what you need to do is you need to turn that ISO file into a bootable flash drive. And if we go over, take a look at it, I've actually got a thing here. Open the link. So if you go to Ubuntu and you can just do a basic search of how to install. right? So it'll give you a thing, install Ubuntu desktop, what you'll learn. So you'll need a laptop or PC with at least 25 gigs of storage and a flash drive of at least 12 gigs. So you'll need at least 12 gig. And then basically, when you come here to create a bootable disk, it will tell you the software that you need. So this is a big thing, right? If you need a flash drive, that you can actually boot off of. It has to install a bootloader onto it to allow it to actually boot off of it. You can't just copy files onto it and expect it to actually boot. And so there's different software out there. So I have a Mac here. So there's Balena Etcher. Allows you to create bootable flash drives. Again, it's a free thing. You can download and install. Each one of the operating systems has their own. I forget what Microsoft's is. Windows has something that does it. Ubuntu has something that does it. Basically, you need that ISO file, you need that piece of software, you need a flash drive. Basically, plug the flash drive in, you use the software, you select the ISO, you do the target as the flash drive, you hit go. That will then give you a bootable flash drive. Once you then have the bootable flash drive, you take that to your computer and basically you plug that into the computer that you plan to wipe and reload. Again, do not expect to use this computer for anything else, right? That's why I've got all these lab computers. I've got so many Macs. I've got over 20 Macs, like within, right? And the reason is because I can just grab something, I can wipe it, and I can throw whatever operating system I want on there, right? So basically what you're going to need is you're going to need a computer that you do not care about anymore. You then put you basically put the flash drive in here. You then go to the boot menu. So depending on what computer you have, you may have to do a Google search. With Dell computers, you generally hit F12. If you have an Intel Mac, so again, one of the cool things about Intel Macs is you can actually get to the bootloader component. So if you push Option when you have the thing in there, it'll give you the option to boot off of another device. You then boot off the flash drive. You then say install Ubuntu, and then you go through the process and you can install Ubuntu. It's not that big a deal. It really isn't that hard. We just can't get into it today because it does take a amount of time. Cool. Okay, so we have done the spiels, and Jock raises his hand. Who do you think, Ray? Somebody raised their hand. Guess who it is? Okay, yeah. Anyways, I should not give Jock crap. It's good to ask questions. I wish more people ask questions. See, my point here with Jock is that other people can ask questions too. But anyways. Oh, Jock, what's up?
Hi. I'll be switching to my other computer in a second. So basically, are you switching the operating systems when you do that? Because Mac, which I was told, Mac OS is based off Linux. So are you necessarily, with an old Mac computer, replacing the operating system? Or basically, when you push that flash drive in, just breaking down the Mac operating system that's on there now to its basic component of Linux?
No, you are formatting the drive. So basically, and again, that's why I like these old Intel Macs. Again, I literally got lots of them around. When you boot off of it, you get access to the hard drive more or less like you would in a PC. And so when you install Ubuntu, what you're doing is you are literally formatting the drive and then installing Linux. So the lab machine that I'm about to show you is, again, literally one of these little 2012 boxes. And so you format the drive. You completely wipe the drive, you install Ubuntu on there, and then you've got basically a brand new operating system. Yep.
Second question, really quick.
Yep.
So you mentioned Raspberry Pi. Can you necessarily do the same thing with a Raspberry Pi and use that as a Linux machine?
Yeah. Well, yeah. So. And again, we talk about these distros. So yeah, another distro is actually Raspberry Pi OS, or whatever the hell they're currently calling it. So under Debian is Ubuntu and Pi OS. And so when you go through the process of installing Pi OS, that's simply a version of Debian that's configured specifically for the Raspberry Pi. And again, when we talk about the distros, why Pi OS is useful is... I need some shelves behind me. Anyways, where's my pie? Pie. Got so many pies. I got pies. Anyways, so we got pies here, right? So, When you have a Raspberry Pi, you have different things that you don't have on a normal computer. So you have a screen connector that doesn't look like anything on a normal computer. You have a webcam connector. You have GPIO pins, that type of thing. And so basically, the distribution of Pi OS, the Debian distribution of Pi OS, also contains the utilities that are required to configure and mess around with this thing specific to Raspberry Pi. So you can actually install Ubuntu onto a Raspberry Pi, which is useful. I've done it. But then you might have to then super glue different, like, so if all you want is a web server, you can put that on a Raspberry Pi, no big deal, with Ubuntu. If you want to use Ubuntu, but you also want to use the GPIO pins, and you also want to use some of this other stuff, then since you're using Ubuntu, then you've got to start adding to the Ubuntu installation the tools that will allow you to use these different things. Does that make sense?
Yep. Last question, but I think I already know the answer to this already because we mentioned about the drivers.
Yep.
If I can put a flash drive in an old game console and change the drivers, would I be able to use that as a server? Probably the answer is no. We talked about this before.
Yeah, game consoles got locked down. So if you can find a PS3 from like 2006 era, go for it. They hardware lock those down though.
I actually got one.
Okay, well, try it. As long as it hasn't been, I don't know, there's a whole bunch. Okay, talk about that after class. Sort of, yeah.
Copy. Thank you.
Cool, yeah. One of the Christophers, I was going to ask. Christopher had your hand up. Do you care? Christopher, oops, admit you. Oh, we got two people. Oh, yeah. And I swear to God, if you're hackers, please stop. Christopher Navarez, what's up?
Hey, how's it going, everybody?
Yeah.
I was just going to supplement what John was saying, because within operating systems, there's a hierarchy in their language, Unix being the highest, and then you have your lower languages within those operating systems, or within the operating systems going down. Excuse me. So I was going to just mention that before, because you have Unix, then you have Linux, then you have, Mac is kind of based on, Cocoa is kind of based on Unix, if I'm correct. And then you have everything in Linux, and then Windows and OS2 Warp, which is back in the 80s, and all that other stuff. So,
Yeah. Lots of stuff. Lots of stuff. Cool. All right, let me get to. Do you have do you have a question, or just want to point that out?
No, that was it.
Okay. Let's see here. Dylan, what's up?
Hey, is there any reason why you wouldn't just use, virtualization to do this instead of installing directly on hardware?
You can. I haven't taught you guys virtualization yet, so yeah. Yes. So if you know what he's talking about, there's something called VirtualBox, which we will have a class in the future. And again, we had the cloud computing class. We're talking about type 1 and type 2 hypervisors. So VirtualBox is a type 2 hypervisor. Basically, with that, you can install the hypervisor onto this computer, and then you can install the operating system into VirtualBox. And then you can be running it as an operating system that's in there. But again, as I say, there's 20 ways to skin a cat, and I only have enough time to teach you 3. So, yeah. If you do raise your hand and I answer a question, do keep yourself unmuted until you're satisfied, because to unmute you, we have to go through this whole process. So ask a question, stay unmuted until you're happy, and then you can mute yourself. Jenny? Yep, what's up?
Hi, you had mentioned about kernel before.
Mm-hmm.
I just grabbed the concept what that means.
The kernel? So the kernel, as you got the hardware, right? So I say, you look at this, you can actually see the hardware here, right? So you have all these components here, these hardware components. So the kernel is essentially the layer between the software, so this kind of stuff, and the hardware. It allows the software to be able to communicate with the hardware. So things for like hard drives, when you actually open something like a file, there's a whole process that has to happen for the computer to be able to go to that file, open it up, turn that into something that shows up on the screen or to save it. So basically what the kernel is doing is it acts as the middle between the hardware and what you would normally think of as a software.
Is that like so is there a server for that? Because I've heard there's some kind of server also.
So it's part of the operating system. So we take a look at the whole stack of a computer. I talk about tech stacks, right? So we got this thing. So think about this. All right. So we have so basically up here we have all the software that you use, right? So this will be like Firefox and Word and whatever else. Under this, we have the things that you think of as the operating system. Add or remove programs that can allow you to install programs. A file manager that allows you to go through and look at the file directories, all of that kind of stuff. And then here, basically you have the hardware. And the hardware is the hard drive, the RAM, the Wi-Fi chip, all that. And so basically what the kernel is the kernel is this layer here that allows the communication from the hardware up into the stack and from the top of the stack down to the hardware. That's what the kernel is.
Okay, thank you.
Yep. Yep, and feel free to ask questions. Again, I'll just tell you, and again, I'm not mean about any of the questions. So there's no dumb questions. There might be inappropriate ones. So if it is, again, like talking about hacking consoles, more than happy to talk about it after the class. But yeah, any of these questions, if you get lost on what a kernel is or anything else, I can stop and we can talk about it again. So anyways, where are we at? We are at a demo of the desktop. So let's see if this demo goes okay. Because right before class, it was crashing. Okay, so now, there we go. So this, what we're looking at, just so you know, is all I'm doing is mirroring this particular computer. And again, if you have not heard me go all fanboy, people think I'm like mean or snarky about tech. I just get excited about different things. I am so excited about 2012 MacBook Pros. AI, that's cute. 2012 MacBook Pros are awesome. What I'll tell you about these, you can go to Back Market for like $130. You get one of these things. You can slap a SanDisk solid state drive into it, because basically these are the old ones you could actually get into the solid state drive. Throw that in there for $150. You have a beautiful lab computer that you can literally install Ubuntu onto. And for most things, again, not AI, not AI. But for most things, it actually works really well, right? You want to play with Python, you want to play with CSS, you want to play with HTML, if you want to play with APIs. So if you want to connect to OpenAI's service, this is wonderful. If you try to run Ollama on this, not so much. But anyways, this is that. And again, we go take a look at this. This is the GNOME 3. It is the GNOME 3 shell. And this is what I actually use this particular computer for. I literally just have it pinging. We got a lot of quirky ISP connections in my area, especially after the flood. So this literally just sits on my desk doing a continuous ping. So if I have any problems on my computer, I can see, oh, is the internet up or not? That's one of the things you can do with old computers. But anyways, if we go and we take a look at this, we can take a look at what a GNOME 3 shell looks like. Again, we've got a nice little GUI interface, and basically looks like what you would expect it to look like, only you got the little sidebar over here. The sidebar is bigger for some reason. It's getting cut off on here. Let's see, if we go and we take a look at this, right? So we can go down here to click on Show Applications. If we click on Show Applications, we can see some of the applications that are installed. So we have like LibreOffice here. If you want to do, office productivity type things. We have Cheese that allows you to see if the webcam is working. Basically got a lot of basic stuff here. So if you install VS Code will show up here. Basically any of your apps will show up here. If you want to if you want to pin them, where's my terminal? Oh, I guess the terminal's already open. Anyways, if you want to pin something, essentially you can right click and you can do add to favorites. and that will put that over on this side of the screen. If you want to install things from the desktop, basically, there is a little Ubuntu software thing. Again, you get a store, basically like you get stores on any operating system at this point in time, and you can come in here and you can do a search, right? So if you're going to be doing VS Code, so we click on search, we type in VS Code, we hit enter, and then we can see code editing refined. Oh, I guess it's already installed. So anyways, all you would do here, if you want to install something, is you click on it, you then do install, and then that will install that onto the operating system. So this is all the productivity type thing. So if you know the difference between what a server is and the desktop is, this is all this kind of stuff, right? So VS Code, you can install LibreOffice, Adobe products, you can install that through basically that little store right there. Beyond that, it has Firefox. So again, normal web browser, you go to CNN.com. Because we always go to CNN.com. I've been using CNN.com for so long. Oh, I've been using CNN.com as an example before it was a controversial example. Remember back in 2009 when you could say CNN.com and nobody thought twice about it? I miss those days. Anyways, you can go, and again, like I say, basically this is the web browser that's built in. It's a nice modern Firefox web browser. You can install Chrome on a Linux and some other web browsers if you want them. Genie got kicked out or came back in. So we got the web browser there. One of the things is when you do install this, you might run into some weird issues with device drivers. So when you go through the installation process, basically it's next. 99.9% is next. You're going to get one screen. You're going to get one screen, and it's going to ask you if you want to install third-party drivers. In that screen, you say yes. So for things like Wi-Fi, or maybe even for graphics, there might be proprietary drivers that do not work properly unless you install them. This is one of the weird issues you get into Linux and the open source world. Oh, sometimes in the open source world, you have people that are so pure, they make it so nothing works, right? So proprietary drivers are proprietary. They are not open source. But you also need the damn things for the hardware to work. So again, you can have free drivers. You can have drivers that can be freely distributed and freely used and the whole 9 yards. But if you can't see what makes them go, they're not open source. So one of the issues you can have when you're installing the Linux operating systems is sometimes they will not install anything that's not open source, including the drivers you need for your damn computer to work properly. So anyways, so when you go through, make sure to click on that third-party driver thing to actually install them, or again, things like Wi-Fi. And that's the thing, you'll install it and be like, oh, Linux doesn't work for this. And it's like, no, you just need the drivers. But anyways, you can come here. Again, they have the additional drivers things. This might show you different drivers you can use on your particular box. So this was the computer I was going to try to use for today's labs, and it has some issues. And with that actually has a different video driver or video card than this computer does. And so they actually have multiple options here, and you actually have to switch and find the perfect option in your graphics card to get it to work with a big screen like this. So if you're having weird issues, again, maybe with Wi-Fi, or maybe connecting to a big screen, you come to the additional drivers, you click on them, and you try to figure out what's going on. You get to troubleshoot. You get to have fun. Let's see here. Beyond that, I mean, there's not a lot more here to the desktop. This is one of those things, you just come and you play. It is a bloody desktop operating system. It's free. You put it on a lab computer so you're not worried about destroying anything. Just come and play. I don't think you're going to do anything too horrible. The big thing here, though, is the terminal. The terminal, right? Can I actually increase the size? Control, increase the size? Oops, I cannot increase the size. How do I do that? Anyways, basically, what the terminal is here, this is what gives us access to the command line, or this is the command line. I know this might be hard. We're going to get into this a little bit later. This gives us the command line. The cool thing about this is that this gives us all the power of the server. So if I want to install Apache 2, Apache 2 is a web server, and we'll do that a little bit later, you can do sudo apt install Apache 2. Again, you may not be able to see that. But when I do this, this will actually install the full Apache 2 web server on to this box. And the cool part about that is then when I'm doing testing and troubleshooting the whole 9 yards, I now have a graphic user environment for me to be interacting with Apache 2. So if I need to go through and navigate through the file structure, I can do that. If I want to go to the loopback address, 127.0.0.1 is the loopback address. I can do Firefox. Actually, let me install Apache. Just so you see how this works. Oops. If I can type my password. God damn it. Is the cap locks on? Oh, what is the password for this computer? There we go. Don't forget your password. Okay, so this allows me to install it. And this is literally going through, and this is installing just like it is a server. Because again, as far as the Linux world is concerned, the difference between this computer and a server is just that the GUI exists. So it's going through, it's doing its deal. Hopefully it'll stop in a second. Okay, so we get the thing. So Apache is now installed, and so why it's useful to use a GUI environment when you first learn how to use Linux is because now I just installed Apache, and I can go to 127.0.0.1, which is my loopback address. Anyways, I get a bad gateway error. So it means something is installed. Anyways, this was not the computer I was supposed to use for today. Anyways, showing you a bad gateway error, I know this may not seem right, but that actually shows you that a web server is installed on this computer, and we gotta do some troubleshooting. But the idea is I would install Apache, I would build my little web app, and I could go to 127.0.0.1 in order to troubleshoot and see what's going on the whole 9 yards. Jack, what's up?
Does it matter when you're trying to do Ubuntu and install Apache and all these other applications, does it matter how much RAM or other piece RAM or storage is in the computer we're trying to use, like a Raspberry Pi or old Mac? Does that matter a lot or not so much in the examples you're showing us?
What do you think? You've been here for a while. I get to ask questions back. What do you think?
I'm thinking like for the applications we're trying to do, not so much, but it depends on what we're trying to do in a sense.
Yeah. Yeah, basically remember, server services are basically just server software. It's just like your normal desktop computer. If you're going to open up Notepad, you don't need a hell of a lot of resources. If you're going to be opening up Adobe Premiere, you need a lot of resources. Right? So a lot of the stuff that I've been, and again, I have to be careful because when people are watching this later, what I've taught you up until this point, you don't need a lot of resources for most things. But Olama, you do, right? So we had the class on Olama. So Olama allows you to run LLMs locally. So if you try to run an LLM locally on one of these things, it's not going to go well. It needs more resources. Where, if, again, as I said, if I'm doing an API call, so an API call is just Python communicating out to somebody else's server, then I don't need basically any resources. And so that's where you're going to have to figure out, again, what is your particular server doing to determine, again, RAM, hard drive, the whole 9 yards.
Copy. Thank you.
Yep. And that's going to be like the big thing nowadays too, is that we've got so much of these AI services out there. And again, they're great, but, yesterday the Raspberry Pi 5 was a pretty powerful computer. You try to throw LLMs on this little thing and it's probably not going to go so well. So again, it depends on, what you are trying to accomplish. Okay, let's see here. And basically, like I say, from the command line, again, you do clear and you do something like top. Again, might not make a lot of sense to you right now, but basically this is just showing you that you can get to all of your command line tools just simply by using terminal, and you can play around with it. Any question on the desktop? It really is one of those things, you know, play around and find out, as they say. Any questions? Cool. Okay. So, let's see here. Okay, so that's the desktop. So you're going to hear about SSH. This is called Secure Shell. So basically all this is this is a utility that allows you to be able to remotely access your Linux computer. So the Secure Shell will remotely access your Linux computer at the command line level. So basically that looks like, essentially like this. Control C. Control C. There we go. Where are we at? Oh yeah, we're one of those days. Okay. So basically, I have this Ubuntu server sitting up on DigitalOcean, and basically this is a version of Secure Shell here, right? So I've got my computer that's sitting here, this computer that's sitting here, and I can type in commands. Again, if I want to do LSL, if I do PWD, I don't know, it shows me different things here. Why is that? Come on. Anyways, it's being wacky. But basically what Secure Shell allows you to do is it allows you to remotely access the server and be able to run commands on it. Again, basically, essentially as if you're sitting there using it at your desk. The big thing with this is you can use this in your local environment. So if you have a server just sitting in the other room, or sometimes if you have a rack of servers and you don't want to mess with it, you can SSH into any of them, or you can remotely access them literally from anywhere in the world. So this is what the port that's used is something called port 22. So we've had a class in the past, TCP/IP, and ports are the ports that are used for specific software. So there's an IP address, 192.168.1.20, colon, and a port number. That port number is basically the service that you're trying to access. For SSH, it is port 22. So if you're trying to SSH into a server, make sure that port 22 is open. And if you don't need to SSH into a server, make sure that port 22 is blocked. So that might be an issue that you're running into if you try to SSH on a machine and you're not able to. Most likely there's a firewall rule that's set up that's blocking you from doing that. Dylan, what's up?
Could you explain why you would use SSH instead of Telnet?
I don't know. Why would you use SSH instead of Telnet? Do people still use Telnet? Is Telnet?
Not really, but I figured it would be good to bring it up.
Oh, crap. Oh, you people. I don't, fuck me. Sorry. Last time I used Telnet was damn near 24 years ago, so I don't know. We use SSH. Yeah, Telnet, so again, like any of these tools, there's many different ways to be able to access. There used to be a utility called Telnet that allowed you to remotely communicate with a server. Again, after class, I will do some research. I swear I have not seen Telnet in the real world since 2001, so I don't know. BPub, what's up?
Hey, it's Ben. The most obvious explanation is right in the name. SSH is secure shell.
Yep.
It's encrypted.
Yep.
Telnet is not. Telnet is plain text.
Ah,
so security.
Okay. Ah, fair enough. Back in 2001, we started caring about security. Okay, cool. Cool. Any other questions? Oh, no, you're good. Okay, so yeah, so secure shell. Yeah, and that's gonna be one of the things too. Is like once you start doing administration and that type of thing. Again, like looking at your environment and doing some research on why do people use whatever it is that they use. Again, that's actually a very good example of like, why do you use SSH versus Telnet? And frankly, that I couldn't give you a good answer. If I was your boss, it would then be your job to go do some research and figure out why it is you do whatever it is that you're doing. You might still be using Telnet. Again, if Telnet works, right? Yeah, that's one thing, legacy systems, right? I don't know how, but if you had Telnet set, somebody set up Telnet, let's say 15 years ago, and you've just been using Telnet, your organization has just simply been using Telnet for the past 15 years, right? That might be a question of why are we still using Telnet instead of SSH? People say, well, because we've always done it. You go do a little research, and that might be a way to move yourself up the food chain to show, hey, we should be using encryption or whatever else. Again, actually an important thing to think about. Let's see here, sudo. So sudo is going to be an important thing to remember, and it's probably going to get you into a lot of trouble. So especially with Ubuntu, again, different distros of different distros of Linux do things slightly differently. One of the nice things with Ubuntu, and I do believe it's all through Debian at this point, is that when you create your user account, you are not going to have root privileges by default. You may be root, but you can't always act as root. So we talked about this in the cybersecurity world before. Like one of the big problems in the cybersecurity world is you get some old-time crotchety, jackass administrator like me, been doing it way too long. I'm burned out. I don't care anymore. And so I've started checking my email as I'm logged in as a global administrator. Right? So somebody sends a spear phishing attack to me, I click on that link, and the issue isn't even that I clicked on the link. The issue is that when I click on the link, the script that fires off will have the privileges that I'm currently logged in under. If I'm a global administrator, it means that script basically now has control over my entire DIME network. Everything goes to hell. So one of the nice things with Debian and with Ubuntu is when you log in, even if you log in as technically the administrator account, what's called the root account in the Linux world, you're not by default given those administrative privileges. If you want to install software, if you want to mess with files that you don't own, those type of things, you have to do something called privilege escalation. You have to escalate your privileges so that you actually have that root layer level access. So that's where you use sudo. So like if you do apt install, and so that's how you would install an application. Well, like I just showed you with Apache 2. If you just do apt install, it will fail out because you do not have the permission, right? So think about this. This is an important thing to be thinking about, like with the bad USBs. Rubber duckies. They're called rubber duckies. Anyways, there's these things called rubber duckies. Basically, you can plug them into a computer. They're a USB device you can plug into a computer. Basically, the computer sees it as a keyboard, and so when it gets plugged in, it will literally start firing off keyboard commands as fast as it can go, right? So if you plug this little keyboard thing in and it starts trying to administer the server you've plugged it into, if it doesn't know how to escalate the privileges, hopefully all of those commands will fail out. So if you try to do apt install or something like that, that'll fail out. So what you do is you use the command sudo, basically as I call it, super user do. People argue with me over that. I don't know, it's an easy way for me to remember it. I think of it as super user do whatever the command is. Essentially root do whatever the command is. So as root, install an application. As root, remove an application. As root, move this file. Blah, blah. So that's basically what sudo is. And so when we're going to be running administrative tasks, you're going to put sudo in front of it. When you put sudo in front of it, it is then going to ask you for your password, like it was asking me. And if you don't have the password, it'll fail out. If you do put the password in right, it will allow you to go and do whatever administrative tasks you're trying to do with the systems. So let's see here. Oh, this is weird. I can show you some of this stuff. How am I going to do this? I don't understand why this is. Why is this screen too big? Why is this screen too big? I swear sometimes. Move and resize. So, all right, 1 second here. So this is coming from DigitalOcean. I open up another console. Yeah, it's weird. It's like it's too big. It's too big. Can I just, maybe if I, yeah, okay. Oh, troubleshooting on the fly. Okay, hold on 1 second. I don't want to quit Safari. I just want to. You ever had one of those days? Come on. Move and resize. Bring all to front. Because I need to show you stuff. What's going on? Hold on. Oh, golly. Again, as I say to all the new people, really? Are you passionate about this? When you see me losing my damn mind in real time, is this what makes you excited in life? Alright, so that's that. The hell? Oh, okay. Huh, there we go. That's all working. We got a thing working. Christopher, there we go. Let me have a question to be a palate cleanser.
I was going to make a suggestion.
Yeah.
But you already got it, so
Okay.
it was your display settings.
Yeah, cool. Yeah. Okay, so can I increase the size? There we go. Okay, so we're going to do clear. Okay, so I got root. So basically, when we're looking at this, and we're looking at our stack, just so we understand what's going on, right? So I'm here in my house, right? This is me, this is you guys. We are connected to the cloud. In the cloud somewhere there is DigitalOcean, and this is a droplet. This is something called a VPS, or a virtual private server, and it is running Ubuntu on it. Pretty basic stuff. Basically, you just go to DigitalOcean. $6. I do have to say, don't buy the $4 a month plans. They suck. The $6 a month plans work very well. You can go there. You can get a virtual server, and basically, again, for the SSH, basically the console into it, there's this little link that allows you to console into it, and then that will give you this screen where you can start playing around with stuff. Right, so again, for the sudo command, can I increase the size? Okay, that's about as big as we're gonna get. Hopefully that works well enough for you. I'll explain what's going on if you can't see it. So if I do, let's see, apt update. So one of the first things you're gonna do, as soon as you have a brand new server that's up and running, or Linux box up and running, is you want to update the repository information. So the cool thing about Linux, since this is free, since this is open source, you don't have to worry about proprietary crap, right? You don't have to worry about license keys, you don't have to worry about media. They literally put these repositories up online decades ago at this point, and you can basically just access them to install essentially whatever software that you want. So there's a tool called apt. Apt is how you install stuff, install, uninstall, the whole 9 yards. If you do apt update, so that doesn't need sudo. What this is going to do is it's going to go up to the internet, and it's basically going to search for any updates in the catalogs, and it's going to download that information so that it knows what is currently available. Past that, the next thing you need to do, and for this you need to do sudo. So if I do apt upgrade, apt upgrade will do the, will this actually work? Do I not need sudo on DigitalOcean? Sudo is not required on DigitalOcean. That's a bit concerning. Anyways, if you do apt upgrade, sudo should have been required. Basically what this is going to do is this is going to download all of the updates for your operating system. So again, especially when you're going to be deploying something new, always update the machine. Many times the problems that you're going to run into were fixed years ago by some stupid ass update. So if you update it, especially when it's a brand new machine, you'll be fine. Yeah, that actually ran. I should have needed to put sudo in there for it. Anyways, so basically you do upgrade, and that is what will essentially update your operating system. Jock, what's up?
So basically, for DigitalOcean, because it's an online service in a sense, we're just configuring it now to Or we're just configuring out as a new server, so we probably don't have to do sudo. But if we're doing our own like server, then we use like the sudo command to do all these operations in a sense, correct? Am I thinking about that right?
Well, no, it's just here. Let me go to the other one. No, it should just maybe I'm wrong. Maybe I'm wrong with upgrade. But let's see. So this is my box. It's running here. So Control C. I don't know. Apt upgrade. Yeah. Okay. That's what's supposed to happen. You may not be able to see it. So this is Ubuntu that's installed on this machine. If I just simply did apt upgrade like I just showed you, permission is denied. So if I do sudo apt upgrade, it'll ask me for my password, and then it'll run through and it'll do it. So that's what I was expecting to happen on DigitalOcean. This is supposed to be a distro, an operating system type thing. So sometimes you don't find out quirks until you're actually working on things. Again, that's where I say is, use equipment. Use, test, because things do weird stuff sometimes. So I don't know if, so it's not digital, it's not supposed to be crap. As far as I know, it's not supposed to be DigitalOcean. I need to do some research. I'm not sure why that worked. It should simply be Ubuntu requires you to run sudo before the command. I'm not sure why that functioned.
Second part of this. So we've always worked in the root directory on our computers. So with DigitalOcean, we're able to the root directory will be able to access that on our computers. With your box that you have that you're working off of, we can access the root directory after we do all the other functions. Am I understanding that correct?
Yeah, they're just servers. So yeah, this is the thing. This is DigitalOcean. So I log in, I do pwd, oops, not pwds, pwd, and that just puts me in a root. So this is slightly different. So if you're on this computer, it'll create home and then a folder for whatever your user account is, and that will be your user directory. This thing creates the root folder at the root level. So this is where your root is. So again, pwd is a command I'm going to show you. Is that when you log in, pwd shows you where you're at. So this is where you're at when you log in to this particular machine. And so you're going to be at the root is where you're going to be. I don't know if there's any files in there. Yeah, no files in there. I don't know if that makes any sense. So basically,
I think I got it.
Yeah, when you log in to find out where your user's root directory is, and again, we'll talk about this in a second, use this command called pwd, and that's going to show you where you're at. So if you initially log in, this will show you what your root is.
Gotcha.
Cool. It's one of those days. Linux, it's so easy. Yes. Anyways, oh god, what's up, Dylan?
Hey, I believe that worked because you're logged in as root on that machine and you're logged in as a user on your other one. So you don't have to use sudo when you're logged in as root.
But I thought with Ubuntu, again, maybe something. Again, I've been doing this stuff for a while.
Maybe I'm wrong, but I mean that's how I've learned it.
But yeah, I thought with Ubuntu you weren't able to really log in as root. I thought you had to go through these. You can theoretically log in as root, but I thought you had to jump through hoops in order to get it done.
Not sure.
Yeah, okay. Fair enough. Let's see here. Oh, somebody else had a question. That was you, Dylan. Oh no, was that Dylan? No, you're done. Okay. Yeah. Anyways, again, with some of this stuff, play. You think you know, and then things change. This is one of the reasons why, again, a lot of people that are new to the tech field, they get in the tech field, and one of the reasons they want to get in the tech field is so like, Eli, I've always wanted to be smart. I just want a job where I know I go in and people are going to know I'm smart. And what you have to understand with our field is somebody changes a configuration somewhere and all of a sudden, all the crap you thought you knew doesn't work anymore. This is a profession of dumb people. If you want to spend your entire 40 years as a professional feeling stupid, this is the field for you. Anyways, but it's always an experience. You always get to learn. So yeah, okay. So sudo apt. Normally, sudo apt update. This is going to update the catalog. Install updates. To install the updates, you do sudo apt upgrade, and that will basically upgrade your computer, do all the updates for this particular version of the operating system. So there's those versions 24 and 22 and 23. So this will update this version up to its latest version. It doesn't upgrade you to the next complete version. Then if you want to install an app, as I showed you before, we can do sudo apt install and then whatever it is that you're trying to install. So if you're installing Apache 2, so this is a web server, this is a boomer web server. I like to use it. Anyways, Apache 2, old school web server. If you're going to do Nginx, you do sudo apt install Nginx. Python, or some of the Python modules that we use, Python opencv, sudo apt install, blase blase. To remove the app, if you want to remove it, it's simply sudo apt remove, and then whatever package it is that you're trying to remove. And then you have purge. So remove removes the software, but not the configuration files. So you might want to do this from a security standpoint. So let's say you installed something onto your server. It's not quite doing exactly what you wanted to do, so you want to go back and do some more research. You might remove it, leave the config files there, so they're still there, to come back later and reinstall it, and you still have the config files. On the other hand, if you install something and you just want it gone, it's just not doing what the hell it's supposed to do, if you do purge, purge will delete the configuration files along with the software. Christopher, what's up?
So how does Apache work? I don't know if that's a question to ask, because I know that when I install the Eclipse, you have to install Apache first and then install Eclipse. And just because of life, I couldn't, so I was always trying to understand, why do you have to install Apache?
Oh, so Apache is, okay, so we can do this. So we got this right here. So we can go, so just to show you, so crappy-app.com, right? So this is the domain name that I own, crappyapp.com. And as we can see, we get absolutely nothing here. So crappy app is actually currently pointed, hopefully, towards that DigitalOcean server. So I can do sudo apt install Apache 2. It's going to go through, it's going to ask, I'm going to do yes. It's doing that for some reason. It reloaded. Okay, let's go here. What happened? Sudo systemctl status Apache 2. Oh, no, not Apache. Apache 2 could not be found. Nope, nope. Let me just try to run the command again. Install Apache 2. It's already installed. Okay. And of course you're causing me problems. Hopefully the IP address works. I'm going to copy the IP address. Oh, hold on one second. Rewrite, execute, rewrite, execute. Crap, that was going to be a really cool thing. This is just, oh yeah, we're one of those days. Why is Apache 2 not working now? Come on, work for me. You know you want to do it. You know you want to do it though, Apache 2. Oh, fuck. I'm an idiot. Or I'm an idiot. There we go. So what Apache 2? So this is the IP address of my server. So DigitalOcean. So DigitalOcean, this is my droplet up here. This is the IP address of that. So I can plug that into my thing. And when I do, this is basically the default page for Apache 2. So what Apache 2 is simply a web server. So Apache 2 Nginx, if you're in the Windows world, something called IIS. This allows you to serve websites to people. And then basically you just change this out in order to build out your web application. So if you want to go, yep.
That's now the content of your website is stored within files on the web server that you use, like FileZilla, to transfer.
Yeah, however you end up transferring it. So this is all big again. Anyway, can you see that? So yeah, if you come down here, so I did this LSL command, and so in the var www HTML directory is index.html. Index.html is this.
Okay.
So when you build your web app, you're just going to have a lot more files basically in there. And it defaults. So if you'll see, it'll either be home or index or default, either HTML or HTML or PHP or whatever if you have other languages, but it always defaults to one of those. So if you're going to build a little web server and you just like a one-page thing, just make it default or index.html or .html, and then it will just automatically dump you onto that page.
Okay.
Yep.
Right. Thank you.
Yep, no problem. Go on like me then. Yeah, and so that's basically, and that's the thing to understand about these Linux servers or these Linux services. You literally just install whatever you need, right? So for me, like, and again, like I say, that's the whole thing with like 20 ways to skin a cat. I know it's a gruesome expression, but I don't know. People used to not like cats for some reason. Anyways, when I talk about that, it really isn't a joke. So like Apache 2. So if I just need to deploy something really quickly, again, I'm old school. I've been using Apache 2 for 20 years, so I keep using it because legacy. But it's really easy, right? If I need to throw HTML files up, I use Apache 2. If I need to throw JavaScript examples up, I use Apache 2. If I need to do PHP, well, some classes on PHP, I'll use Apache 2. Because again, to me, it's just very simple. But then when we go to deploy Bottle apps, right? So we've been doing those projects with Bottle. If you're going to deploy Bottle, there's another web server called Nginx. So Nginx works very well, not just as a web server, but something as a reverse proxy server. And Gunicorn is a Python web server that basically has been designed to use Nginx. So the reason I would install Nginx is because that's what Gunicorn wants, and Gunicorn is what I'm using to deploy Bottle, and Bottle is on Python, so therefore I use Nginx. And so like that's where, again, like your job as a tech professional is basically sitting at a whiteboard and figuring out requirements, and then basically just painting by numbers to decide what you throw up. It really is about that simple. So yeah, if you're going to install, install, uninstall, or remove and the configuration files. Donna, what's up?
Just a quick question. So you need NGINX also for Django, right?
Yeah. So, well, it's not really for Django. So, just extra classes, extras. Yeah. So we talk about the stacks. We're going to talk about the stacks. And so basically, when we start talking about this web app, so you have Python at the bottom. And so we normally use Bottle. So Bottle is the web app framework that turns basically Python into a web app. A much better, honestly, much better web app framework is something called Django. It's everything including the kitchen sink. But the thing is with Django, so Django is the web app framework, but then on top of that, you actually need a Python web server. So there's a default web server literally built into the Python language, Like just calling a module, you can theoretically throw something up on a web browser if you wanted to, but it's really crappy. It's just designed. It's designed to allow you to prove a point. That's about it. So if you actually want to deploy a Django or Bottle or other kind of web app framework, you need a more robust Python web server, and so that's where Gunicorn is the web server. So basically, it's multi-thread. The big thing with Gunicorn is something called multi-threaded. So if you use the web server that's built into Python, it basically can only do one thing at a time. So one person makes a request, they get a response. One person makes a request, which is fine. Like if you're just doing it on your computer, who the hell cares? You start getting a couple of users from the outside world, and single threaded goes to hell. So Gunicorn allows you to do multiple things at the exact same time. So there's something called workers. Each worker, I think, can do 4 tasks. So you give it 4. Anyways, so basically that is what's called a multi-threaded Python web server. Then what you do is Nginx is used as the reverse proxy server. So that then connects to Gunicorn. Nginx, again, is a reverse proxy server. It deals with communication stuff. And so basically people come from the outside world, they hit Nginx. Nginx then hits Gunicorn, and then Gunicorn presents what you did in Django, Bottle, or Flask or whatever else.
Okay, thank you. I hadn't heard of Gunicorn before, but
Yeah, Gunicorn is, it's not too bad. There's a number of these out there. Again, we use Gunicorn because it's the popular one, and that's what we do for class. Yep. So yeah, that's kind of how it works. Make sense?
yeah, thanks.
Cool. Okay. Yeah, and again, like I say, that's the thing with technology. It's all simple. It's just one thing gets layered on another. Okay, so then we got Nano. So basically what Nano does is basically, it's a very simple editor. And so whenever you're going to be dealing with Linux, most of the stuff that you're going to be dealing with is basically text configuration files. Again, if you go back to the cutting edge days of 2000, we wanted all GUIs. Right click and left click and that kind of crap was cool and sexy. Config files were old, and now they're new again. So that's kind of how the technology world goes. But the thing is whenever you're going to be dealing with Linux, again, Squid, Samba, Apache, Nginx, Gunicorn, basically these are going to be text files. They will have a different extension at the end just to tell you what kind of file they are, but they're basically just text files that are going to have a whole bunch of configurations in them, and so you're going to need to go in and modify those configurations to change whatever it is you want to change. Again, a host file or host file, we talked about that in the class. Any of that, you just open it up with Nano as a text editor. We can go, and so like here, again, I've got my little command prompt here, so I can just do like nano hello.txt, right? And when I do that, this is what we're going to get, right? So we're just going to get a nice little thing here. We get some options down here, and then we can write something. And I just say hello world, right? And that's basically all it is. Again, if you go into a real configuration file, there's going to be a lot more stuff here. Then you hit Control X. It'll ask you if you want to save. You hit yes, you hit enter, and now it's saved. If we list the items in this folder now, we will now see that we have a hello.txt file. Oh, am I there? So, okay, so I'm in the var www HTML directory. So what I can do here is I can do a nano hello.html. So now I'm in an HTML file. I'm sitting in the root directory of Apache. So what I'm going to do is h1 hello world, close h1, and then come down here, do p, I made a website. And so again, if you know HTML, all I'm doing is I'm creating an HTML page, .html, h1 tag, hello world, p tag, I made a website. So what's cool here, I'm going to do Control X. Do I want to save? Yes. It'll ask me the name, so just leave it as it is. Now what's cool Now it's cool. All right, cross your fingers, cross your fingers. Hello.html. Oops, what? No. What the hell just happened? Copy. There we go. Yay, it worked. Right, so I went to my web server, 146.190.43.44/hello.html. So basically, when I go here, that is directing me to this text file that I created. The text file is formatted with HTML. So I get hello world, I made a website. So any place that you are at, you should be able to go and you should be able to access this. So again, 146.190.43.44/hello.html. And now we have a globally accessible website. Yay. Something worked. Something worked. Okay. If we go down, we take a look at services. There's not a lot to show you with doing this kind of thing. So there's something called the systemctl command, and this is where we can interact with the services. One of the big things to understand, again, with those configuration files, so we didn't modify any configuration files today, but if you go in with Apache, there's something called the vhost file, other things, there's configuration files. Until you restart the service, so every time that service is started, it pulls in the new configurations, and then it will run based off of the new configurations. If you modify the configuration files, but you do not restart the service, it will continue running as the old configurations, and you will lose your damn mind. Anybody been there? Anybody spent half a day and forgot to restart the damn service? So that's an important thing, right? Because that's a lot of new people. You sit there and you're going to be doing a lot of typing, coding things out. If you do not restart the service, none of the changes you have implemented will actually go into effect, and therefore you're literally troubleshooting something that never went into effect, which is a fun time. You do sudo systemctl status, and then whatever the service is. So let's say Apache 2. So again, sudo system CTL status, and then Apache 2. And so this is a big thing, right? So again, if you have the server up and running before you want to tweak with anything, you might want to see what particular services are running. And then I do this, and again, I see active, it's running, it's been running since this particular time, and it gives me some additional information. So I can use that for troubleshooting purposes. Control C. Beyond that, basically, you have the ability to restart. So you can stop the service. So if you want the service stopped, you can just stop it. If you want to restart the service, is what you'll need to do is you simply do restart, and you do that, and it restart the service. So it brings in the new configurations, and then you're running with that, whatever the current configurations are. Beyond that, so you got start, you got stop, you got restart, and then you have enable. So this is an important one, especially when you're going to be installing things onto your server. What enable does is basically it tells the server to start the service at boot up. So again, one of the issues you can run into, again in the real world, you get the machine working perfectly, everything is going great, you go home, and then there's like a little gray out. You know how like the power doesn't completely go out, but it just blips, and when it blips, your server blips, and then your server reboots, and then nothing's working. And the reason is even though you've installed everything, if you didn't enable particular services, they may not restart when the system restarts. Again, different things to start playing around with. Let's see where we at. Okay, then we got security. So in the Linux world, security is relatively simple. Again, if you're used to the Windows world, you can be a professional that just deals with Windows security. That's not the case in the Linux world. Linux, it is dirt simple. Basically, you have permissions. Permissions are based on everyone, users, and groups. So who is the owner of the file? Who is the user owner of the file? Who is the group owner of the file? And then everybody else. Those are basically the three things you have to worry about. So you have groups in Linux. Basically, you can put users into groups, and that's where the group permission is, right? All resources in Linux are basically objects. Essentially, they look like files. So when we start doing projects, more IoT projects in the future, especially with IoT, with voice and video and that type of thing, permissions for things like the webcam, the video, that is just an object in the system, and you give yourself permission to it, basically as you see fit. One of the things to remember though, if you're dealing with things like webcams, any of those kind of like sensitive system resources, many times the settings for like the user or whatever revert when the system gets rebooted. So you may have to add yourself to the group owner of something like your video camera, rather than try to make yourself the owner of it. Again, you get into some weird security stuff with that. Let's see here. To see settings for all users on the system, we can do cat etc password. Cat. So whenever I do this, so cat basically allows you just to simply view a file. So nano allows you to edit a file. Cat just allows you to view a file. So we're going to say from root, we want to go into the etc folder, and we want the passwd file that is there. And this is basically going to show us the information for the users that are on the system. So yeah, I guess here I've got root. Where's my root? That's not root. Polkit. Okay, so root. So this tells me the username that's here. It tells me what the path to my directory is, and also tells me the path to any scripts that are going to be run in my particular for my particular user. So if you want to go through and you want to take a look at what user accounts are on the system, you would go to that password, that passwd file. Let's see here. If you want to add a user, it's pretty simple. So you simply do sudo add user, and then you can simply say something like new, or I'll say Eli. We'll do it as Eli. If you want to add the user, you add that. So it says adding no user, new home directory. So home Eli is going to be where my directory is. What is my new password? And it'll ask me if I want to do full name and that kind of stuff. You can just click through this. Is this information correct? Yes. Adding user to group user, or adding Eli to group users, and then that's done. If we go back to that password file, we now can see I have Eli, and this is now my home directory. So that's all you have to do in order to add users. So this can be a useful thing, again, especially if you're coming up with a server that's going to be providing services, is many times you may want to just come up with your own user account for the particular app that you're going to be running, and then dump everything into that particular user account, and give it permissions, and the whole 9 yards. Christopher, what's up?
What does client daemon or daemon mean? Daemon.
That is what we call what Google is for. What Google is for. Yeah, there's a lot of stuff in here. Yeah, Google.
Got it.
Yep. That's one thing to be thinking about too, is a lot of the services that are going to be running on your system. There's going to be like, there's services that have accounts, and also like when we installed Apache. So I can tell you about www-data, that one I know. So basically when you have user accounts, users coming into your web server, when they're interacting with your web server, they are going to be seen as user account www-data. So if you need them to execute or be able to do God knows what, you need to give the appropriate permissions to this particular user for that to happen. I know that. Yep.
Thank you.
Yep. Yeah, that's where you can go in and you can deep dive into this. And, yeah. Oh, let's see here. We have groups again, so you can create a group. So if you need to create multiple user accounts, dump them into one group, give permission to that one particular group. Again, you can create a group. You can show the groups and the users, again, with that cat command, cat etc group. Let's do that one. clear sudo cat /etc group. And so this will show you the different users in the group. I think it said I was a user. And put me into the users group. So, Damon, yeah, these are all the different groups on there. Voice, CD-ROM, tape. So again, this is one of the things to be thinking about too is if you need access to a particular piece of hardware, many times there'll be a group assigned to that, so you give yourself permission to that. www backup. Anyways, so I thought it was in the users group. Oh, okay, there we go. So we got the users group, right? So when I created my new user account, I was put into the users group. This is the ID, just ID, a number ID for the users group, and this shows you the users that are in that group. So if I added 50 more users, it would be Eli, comma, Bob, comma, Sue, comma, Tom, whatever. But you can come into here, and again, to see who has privileges to do certain specific things. Oh, Jacques, what's up?
So I'm not really confused, but I'm just curious. When you're creating your web app,
Yep.
You as an administrator, you're pretty much dictate who goes into what group itself. So why do you have to add yourself as a user? Because you can dictate wherever anyone goes, including yourself as an administrator. I'm not correct on that thought?
For security purposes. Because again, like with here, you're actually logged in as root. So basically, like, if I was going to create a web app, again, so we've been using Python or whatever. So what I would do is I would create like an app user, add user app. That would then create a directory for home app. And then basically, tired. This tries to prevent people from accessing things as root, and for you doing something stupid. So if you need somebody to administer, let's say, the app folder, but you don't necessarily want to give them root access, if you give them the app username account, they can then interact with everything that app has permission to interact with without them being able to muck around with root. So it's a way of trying to create security by creating multiple levels of privileges for different users, right? Root can do anything. And so then I create that app user, hopefully, so they can only interact with the things that they're supposed to interact with.
But you can't isolate that through privilege. The app is designed to give certain privileges, but not overall privileges. Correct?
So as we'll go into in a second. So basically, when you set up permission, right? So when you take a look at it, you'll see. I'll pull it up here. Oh, let's see here. Control C. So we're here, right? Let me clear. So ls-l. All right. Okay. So this is going to show you. So again, this is a concerning thing. So the user owner of hello.html is root, and the group owner of hello.html is root. So basically, if I wanted these to be mucked with, more or less, the root account would have to log in to be able to muck with these. Over here, we show the actual permissions. So it's called read, write, execute, and read, write, execute. So what this shows here is that the user owner has read, write permission on this particular file. I can read to it and I can write to it. I can't execute it if it's a script. The group owner has the read permission to this, and then everybody in the world has read permission to this. And so if you take a look at this, if you've been awake for half of my cybersecurity class, you probably know that you don't frickin' want root showing up here, because that means in order to be interacting with this stuff, you're going to need to be root, which brings up a whole bunch of security issues. So if I set this up, so basically I have a web admin account. So it would be, web admin is the user, maybe web admins is the group, something like that. and then they have access. And that means I can give somebody the web admin username, the credentials to deal with this, and then they're only going to be able to deal with this. They're not going to be able to deal with the entire damn server. Right? Like again, like the biggest threat to your infrastructure is you or an employee. And so that means, again, fat fingering something you shouldn't even be touching to begin with. Again, it's a whole idea of the reason you have a server room with a lock on it is so the janitor doesn't walk in and unplug your server rack. Right? They weren't nefarious. They just needed someplace to plug in the damn vacuum cleaner. Right? So by locking this down, so only the web admin is dealing with this, then that means they're not able to go and futz with the actual Apache, because there's Apache configuration files. They're not allowed to do that. They're not allowed to add users. They're not allowed to futz around with groups. So if for some reason what they're doing doesn't work, it forces them to come back to you and then have a nice little discussion to figure out what the hell's going on before they blow up your server. Yep.
Gotcha.
Yep.
Okay.
Yep. So, yeah. Security. Again, remember, you're going to be the one to destroy your systems. Who destroyed your systems? You. You did. So anyways, I showed you the groups. If you want to change owner, so sudo change own, whatever the new owner is for the file or folder. If you want to change the owner and the group owner, you can do sudo change chown, whoever the new owner is, colon, whoever the new group is, for the file and the folder, right? So if we go back here, right, so I can do sudo chown Eli hello.html. We then do ls-l, and again, this is the point here. So now you can see that Eli is now the user owner of hello.html, and so the user owner has this particular permission. And again, if we created groups, we could change the groups too. Let's see here. If we want to do recursive, so do be careful with this. This is great in lab environments. In lab environments, do not do this in the real world. So what recursive means, whenever we talk about recursive, is it does it to the folder that you're directing at and to everything underneath. Right? So you change permissions, you change ownerships. Not only do you do it to the root folder, but you do it to everything underneath. And so that can be a mess. If you have hundreds or thousands of files underneath that main folder and you accidentally change them the wrong way, that is less than amusing to try to fix. But again, if you run into weird permission issues, you might want to do it in a lab environment just so you can set all the permissions to be wide open so you verify that you're not running into an issue with security. Again, one of the big things to be thinking about as a new technology professional, especially when you're doing coding or whatever, when we talk about the stack, is you may not know where the stack is failing, right? You think it's your code, right? You wrote Python code and it's not running properly. So you go back and you modify your Python code for the next 5 days, it's still not working, and then you give up. I can't be a coder. And what you don't realize is that somewhere, maybe there's not permissions. Maybe there's not the execute permission for the script. So when your script was trying to fire off, security was preventing it from firing off. And so the failure was not your code. The failure was the security setting. So one of the things that you might do when you're creating an app in a lab environment is basically open up the security on all the files and folders within your little app directory to make sure you're not running into weird security issues. And so that's why you do recursive. So you can do change ownership of folder and all contents, sudo chown space hyphen uppercase R, whoever the new owner is, the folder you're pointing it at, and then everything will now become yours. Wow, Linux. Who knew Linux would get people talking? I do 2 classes a week and like nobody asks questions other than Jock. This one, you all are asking questions. This is cool. What's up?
I have another question.
Yeah.
So if you change the permissions, can that be reversed? Can you reverse that? Or once it's changed, it's changed?
Basically, once it's changed, it's changed. It basically, remember in the Linux world, unless you build it, it hasn't been built. So yeah, there's no Control Z. So yeah, be careful. Yeah.
Okay.
Yeah.
Thank you.
Yep.
So okay, that answers my question.
Yeah.
which scares me.
Oh yeah, you should be scared. Yeah, Linux is very scary. Linux can be bad. Okay, let me do Donna. What's up, Donna?
So you were mentioning the lab environment.
Yep.
And again, since I've never had to do anything like this before, is there literally, like, could you show us an easy way that you create everything you have here into another Apache server? Or what are we doing? Creating a lab environment.
So the lab environment would be this thing. Alright, so this is this, right? So this is just me in my home, my little computer, right? So I installed Ubuntu, as I talked about before. And again, as I say, all these commands that I'm running, you're simply running them at the terminal within this desktop environment. So basically, when we talk about a lab environment, you're talking about this. So basically, you can install, as I showed you, and then I screwed it up somehow, I don't know how. You can install Apache onto here, you can mess around with the security settings and all that kind of stuff. So I'm not quite sure what I was installing right there. Installing something. But yeah, so when we talk about the lab environment, it's basically just getting a crappy old little computer, installing Ubuntu onto it, or whatever Linux distro, and then playing around with this. Because the thing is, and again, it's not working here because this wasn't supposed to be the lab computer. When I go to 127.0.0.1, I should be seeing the Apache default page here. I'm not seeing it because I screwed up some configuration somewhere. That make, oops. Are you still?
That sort of answers my question. That assumes I have some big, great server from somewhere that somebody else owns, and I'm working on a lab version to.
But that's the thing. But I mean, that's the thing. Like I say with this. So again, I got this off of Back Market. These are 13-year-old computers at this point. Like to play around, and again, that's what this is running off of. So literally, any computer you have laying around, like if it's after 2010, it should be adequate enough.
Okay, so like I create something beautiful, amazing, wonderful in my Apache web server environment, but I want to mess with some apps. I just pick up another laptop, or is there a way to run two of them on one laptop?
That's where we talked about the virtualization thing before. So, so again, depends on your skill level. Again, like with all this stuff, I mean, there's always a way to do something, right? So there's something called, if you want to play with it, it's called VirtualBox.
Okay.
And again, we will have a class on VirtualBox, but again, it's its own class and it's its own world. So what VirtualBox allows you to do is it allows you to install software onto your computer, and then you can actually install an operating system into that. And it's called a virtual machine. So it's an entire operating system that's basically just a file on your system. And so you can have Ubuntu here, and you could have Red Hat over here, and you could run multiple operating systems on your one host machine. Again. It's a class, though. It is a class.
Okay,
yep.
Thanks.
Yep. Oh, Jock, what's up?
Going off of Christopher's question, I'm confused. If you give some permissions, but you're the local administrator, shouldn't you be able to reverse those permissions? Or am I thinking about this?
No, you can. If you go through and you do sudo change mod blah, sudo change mod blah, like oh, you people. You people. What am I looking at here? Okay, let's go here. Right. So let me just go up to root. ls-l. Just give me some. Okay. Right. So what you'll notice. So this is the folder structure just at root. So these are all the different files under root. And you'll notice user owner, group owner, and then you'll notice a whole bunch of different permissions over here, right? And then imagine all the files and folders under these files and folders. So here's the deal. And I mean, I don't know how many files and folders are in a Linux install. Thousands? So if you did sudo change own or change mod R on a folder, it is going to reset permissions to that folder plus everything under it. Now what you're saying, and again, this is very important to understand the words that you're saying. The words that you're saying are, do I have permission to go back and modify what I changed? Yes. The reality means, though, is again, if we've got all these different permissions and all these different ownerships, and you reset all of them to be one thing, you're going to have to go back to every file and every folder and then change them back to what they need to be. Like, so if I want to do recursive, so let's say Eli is the current user account that's dealing with this particular folder. So I say recursively, I want Eli to own everything. Fine, Eli owns everything. And then you say, oh, I want Jock to own everything now. Fine, I just do recursive, Jock owns everything. But here's the important thing to understand. What if the default was that Eli owns some stuff, and Jock owns some stuff, and Christopher owns some stuff, and Andy owns some stuff, and they had different levels of permission? When you recursively go through, all of that's going to be stripped out. So can you give permission back to Andy and back to Chris and back to Jock? Yeah, but you got to go back and figure out how you're going to find each file and each folder and do that individually. That's where you run into the issue. You have permission to do it, but the workflow to do it is going to be god-awful. Does that make sense?
Yes. Again, there's no auto-correct, in a sense, to do all that.
Unless you build it, don't exist. Nope.
Copy.
Yep. Yeah. Yeah, and that's why Linux, you have to be very careful with Linux. And again, that's why you can have disasters relatively quickly. Let's see here. So change ownership. Again, a recursive folder. If you want to add a user to a group, use this user mod command. -a, g. So -a, this appends the group that the user is in. So if you don't use -a, it'll just put the user into that one group, and then it'll wipe out everything else. So -a appends. I forget what G does. Anyways, that's a command. To change permissions, again, what you're able to do is sudo, chmod, and then it's whatever it is, 777.111.555. Where this comes from is basically execute. The ability to run a script, to be able to run something, is value 1. In order to write to a file is value 2. In order to read from a file is value 4. So if you had 774, that would mean the user owner can do anything they want, the group owner can do anything they want, and anybody else in the world, again, such as a web person coming in, can read. If you want to be able to write to the file, then it would be 2, and so on and so forth. So basically, you just add up these numbers to figure out whether it's 1, or 3, or 6, or 5, or whatever else, and that's where those numbers come from. Let's see here, where are we at? Whew. Linux. We're getting close to the end. Thank God. Okay, so we talk about directory structure here. So basically moving around, again, when you're dealing with a Linux environment, basically you're just dealing with the command line, so it's going to be a pain in the butt. So let me do, yeah, okay, so we're here. So we're in the root directory, right? So if I do the ls command, so simply, so clears a screen, right? So I do the ls command. This is going to give me all the files and folders, and basically in this way. So I don't see who the owners are. It's not listed out. I don't see the permissions or anything else. This is basically just like a dir command, directory command in Windows. If I want to see owners and I want to list it out a little bit different, I do ls-l for a list. And that's what gives me all of this. And so again, this gives me permissions, this gives me ownership, this gives me creation date, and those types of things. One of the things, though, is if you take a look, and you look at ls, you might think, there might be more files here. And so one of the things you can do in Linux is if you put a period at the beginning of a file or folder name, it makes it hidden. So we did ls-a. This will show us our hidden files. That didn't show us anything. Let me do cd/root ls-a. There we go. So basically these are all the hidden files here. So bash rc, cache, config, profile, ssh, a whole bunch of different information, right? So if I did ls, I don't get anything. So if I'm looking for files that might be hidden, you do ls-a, and that will show you the hidden files. If you get confused on where you are, because that's going to be a big thing, like you're just sitting here, and you got this. Okay, you log in, where am I? pwd. pwd is going to show you the location of where you currently are. So I'm currently in the root folder under the root for the system. Pretty simple. In order to change directories, you simply do cd and then wherever you want to go. So if you do cd/, that's going to take you to the root. So if I do ls here, I'm in the root directory. If I do cd under this, and I just want to go into a particular folder, so home, right? So I want to go into the home folder, I simply do home. So as I recall, it's been a while since I've used Windows. In Windows, you use /. That always means you start back at root. So if you just want to go into the folder directly underneath, you just put the folder there. You do home. You can now see I'm at home. And I can do ls-l to see what's in home. Pretty simple. If I want to go up a level, so I'm currently here. Let's say I want to go to cd, I go into cd Eli, right? So I'm in the Eli directory, and let's say I want to go up one level. It's like, oh, I'm in the Eli folder. Let me go up one level. If I do cd, /, that'll take you up one level. So now I'm back in the home directory. And again, all this stuff, it's just, you'll learn it. It's what Google and ChatGPT are for. Just kind of how you move through the system. And you start remembering where files and folders are located. Again, that's the important thing with doing the work. Again, I keep hammering home the idea that you need to sit down and you need to do this. You need to build a Linux server. You don't need to build a Linux server. You need to build 100 Linux servers. One of the best things, back when I got my MCSE back for NT4 back in 2000, I actually went to a pretty good school, and one of the requirements is that we had to build our lab environment for every class. So we had classes twice a week, and twice a week we went in and we installed workstations and we installed our servers and we set up our little lab environment. And the reason is they said, we want you to set up these servers so many times that by the time you go to a job, building a server is boring, right? And so that's one of the things, is basically going through here and doing this kind of stuff. The more you do it, you're just going to remember, you know, where is the root directory for your web documents with Apache 2. It's like var www, depending on the distro or the whatever one you're using, it might be an HTML. I just know it. Like that, you don't make that up. You don't figure it out. You just know. You know the information, or you don't know the information. Let's see here. So changing directory, hidden files, making directories. So where am I at? I'm at home. So let's go into Eli so I don't mess anything up. Clear. So if I want to make a directory, I simply do make dir new folder, and that's all I do to make a directory. If I do lsl, I now have a new folder. Let's say I want to rename a file. So one of the things to remember in the Linux world, moving is either to move a file or to rename it. So I can use a command called touch my file. And again, Linux has so many commands, they got so much stuff. So what touch does, touch simply creates an empty file. So when I do this, I do ls-l. You can see I now have a new file there. So if I want to rename that file, what I would do is mv my file to new file. So I'm going to move, basically I'm renaming my file to new file. If I do ls-l, we can now see my file name is new file. If I want to move it up a level, I could do mv new file space period slash new file. And this is going to be the thing too. Again, don't fat finger this. Don't fat finger it. Remember, moving is the same as changing the name. So if when you're moving it, you fat finger what the new name should be, it's gonna get that new name. So if let's say I do file, or I do new file 1, or let's say I do that, right? I do something stupid, right? I hit enter. So now if I do ls-l, right? It's no longer in my directory. If I go up one level, do ls-l, we can see I have new fill. So again, remember, Linux is going to do what you tell it to do. As long as you have permission as a user to do it, it will do it. It's not going to tell you whether or not it's right or wrong. So do be careful with that. You can copy, so simply copy, again, so copy new fill 3, and then let's see a new file, and then we'll just do old. So this is one of the things you'll see a lot. If you start mucking around with configuration files, one of the things I'll say is copy the old configuration file as a .back. Again, the extension doesn't actually matter. This is for you. The .back is for you. So .back basically tells you that's a backup. And then I hit enter. And now we can see that I have a .back file here. So if I futz around with this configuration file, I totally screw it up. I can simply change the name back to what it was and go from there. So that's how you can do a backup and try to roll back things. Again, if you don't build it, if you don't do it, Linux don't care. Oh, let's see here. Copy, if you want to remove a file, it's rm, what the file is. Remove a folder. Remove directory is a folder. So if I want to do remove rm new fill 3 lsl new fill 3 is gone. Let's see here. If you want to remove a directory, so I can make directory new dir ls-l. So new dir is empty. There is nothing in new dir. So I can rmdir new dir and it'll go away. Right? It's gone. So, but if I make a directory, let's say make directory new dir, and then I touch new dir in a place. Right? So lsl. So I have a new directory. If I go into new directory, I have a file in new directory. Place. Alright, so if I try to remove the directory rmdir new dir, it's going to fail out. So fail to remove new directory, directory not empty. So if you want to remove a directory plus recursively delete everything under it, it's rm r new dir, and then it's all gone. New directory gone away. And again, just commands. Just commands. You will learn them, and then you'll forget them, and then you'll learn them again. One of the big commands that's going to be useful for you is find. So again, especially when you start, oops, Christopher. What's up, Chris?
Sorry, just one quick question. Directory is the, oh, can you hear me?
Yep.
Okay. Directory is a folder, right?
Yep.
Or a subfolder. Okay.
Yeah.
That's all I wanted to know.
Yeah, directories are folders. Folders are directories.
Okay.
Yep. Probably. Somebody will probably pop in and be like, well, actually, what a directory is, I don't care. Yes. For our purposes, it's a folder. Okay, so we need to find something. Basically, we do sudo find where you want to start the path at, An argument, so iname is for case insensitive. So one of the big things in the Linux world, oops, I forgot to put that in this class. Linux cares about case. It cares about capitalization. Again, an important thing to understand here, just so we see this. Touch, if I want to touch Bob, and I want to touch Bob, and I want to touch Bob, I can touch all the Bobs. So these are all individual files, and because the capitalization is different, Linux sees those as different files. So I did forget to put that in this class. Capitalization matters in Linux. So I know in Windows it generally doesn't. I know in Mac it generally doesn't. I know in a lot of like SQL and stuff it generally doesn't. When you're dealing with the Linux operating system, capitalization matters. So the issue that you run into is when you're trying to search for something, let's say an INI file. So INI files, .ini files are generally the configuration files for things. Sometimes you're not sure, what the capitalization is. And so the argument iname is just basically ignore capitalization. Just find me something based off of this particular query to make life easier, right? So you use sudo in this so that you have the permission to actually look in the different folders. So again, everything runs off of permissions here. So if you run find and what you're looking for, basically you're going to hit a whole bunch of folders that you do not have permission to take a look into, and you're going to get a mess back. So by doing sudo, it raises you to that root, find where you want the path to start, iname for don't care about capitalization, and then what the query is. If I do this, so that password file we were dealing with before, let's say for some reason I need the password file. Where's the password file? Or again, php.ini. When we do a PHP class, there's something called the php.ini file. Where the hell is that again? So anyways, when you do sudo, find, start with root. So / is root, that's the highest level in the directory. Hyphen iname, to not care about the capitalization, and then password. So it's PASSWD. I saw that file somewhere, so we're going to look for that. We hit enter, and so it starts spitting it out. Right? User, share document password, share, and then what I'm probably going to want, etc, PASSWD. So that's what I'm going to be looking for. Pretty simple. Again, to start again, when you go out there, you need to find INI files. Oh, it's a pain in the butt. But to show you, if you do not put the sudo, basically what's going to happen is actually this works because it's that root thing. Anyways, if you're on the other machine, and you run this without sudo, it'll fail out and give you a bit of a mess. Then you have grep. So basically what grep allows you to do is it allows you to filter results. So we go over here, right? So let's say I do a ping command. ping-c1cnn.com. Now one of the things too is when you deal with Linux, you do have to understand the operating system. Some of the basic tools may work differently than what you're used to in the Windows world. In the Windows world, at least how it used to be, if you did the ping command, it would run 4 times and then it would stop. In the Linux world, it runs until you tell it to stop, which can cause all kinds of problems. So what we're doing here is ping count of 1 to cnn.com. We get we do this, it's pinging, and then we get the results back. Right? Ping, this is the IP address, and some of this other information. Especially when we're doing projects, when we're running Python code or whatever else, and we just want very specific information. What grep allows us to do is it allows us to only return a line that has like a specific word in it. So we've got time here. So 2 of these lines have time in it, I think. Time there, and time there. So what I could do is ping c1 cnn.com. Then you do a pipe, grep, and then you say time. Now when I do this, all I'm going to get returned back are those 2 lines, and it will highlight for me basically what it's going after. And I might look at this and think, well, That's not too bad, but I really wish I could just get one line. All I really care about is that one received. So loss is here, loss isn't there. So what I might be able to do is do grep and do like loss, and there we go. So I'm pinging cnn.com, and the only thing I'm getting returned back is this one line that has loss in it. Again, this will be a much bigger thing with other commands. Let's see here, IP address. So this is a way to get your IP address information from the command line. So this is my loopback address. This is the actual IP address for the server. And this is my private IP address. So when you have a DigitalOcean server, you have the external IP address that the world can get to. But if you're building an internal network, it gives you this internal IP address. So if I'm looking at this, and like, I only want the INET. Like, there's a whole bunch of information here I don't really care about. What I could do is I could run that command, IP address, run it through grep, but then only ask for lines that have INET in them. And when I do that, then I'm only receiving this back. So it's like, okay, INET 146.90, INET 10, and INET whatever the hell this is. And so again, once you start getting much larger amounts of information back from the Linux operating system, using grep is a good way just to go through and try to get it down to a manageable size. Again, one of the biggest issues with dealing with Linux is you just have so much text to deal with. And just figuring out what in that text matters can be a pain. So grep is a tool that allows you to do it. So basically you just run the command, whatever command it's going to be, then you do the pipe, then you say grep, then you say whatever words it is that you're looking for. Top is basically the task manager for Linux. So we go here, we do top. So this is going to tell us what's going on. So how long this thing has been up for. So this tells me the time, and it tells me it's now been up for about 5 hours. It shows me the load averages. We don't really have any load because I'm not really doing anything with this. I forget these times. So these are averages of different times. It's like this is the 1 minute average, and this is like the 5 minute average. It's like the 10 minute average. You can Google on that. But basically, it's a way to show you kind of like over time how the system has been being utilized. You have the CPU here, basically what's using your CPU utilization. You have your RAM. So I have 961 gigs total. 120 is currently free, 320 is used, 691 is being used for buffer. So again, that whole resource thing, so what Jock was asking before about what hardware do I need to run the Linux server. Again, if things are being kind of janky, you can pull this up and you can basically see what's being used. And then this gives you the different services that are actually running. And you can just kind of scroll through all these different services. There's ways to sort them and all that kind of stuff, but we're not going to get into that. If you need to kill a process, so let's say a process has locked up your system or it's utilizing, there's a tool called kill. And so you look for the PID. This is the process ID. So this is the identifier for the process. So you can use the kill command to kill one particular process from the command line. So you come in here and you find out, oh, this process is process ID 17. You flip out, you do kill 17, and then it'll force quit that particular process. Do be careful with that. Do be careful with that. And then the final thing, we're not going to get in today because it does get to be pretty complicated, is UFW. It's called Uncomplicated Firewall. So this is the built-in firewall for Linux, right? So again, I talked about that before with the whole security, the layers. So whenever you're building your infrastructure, right, you got your infrastructure here. One of the things you should be doing is you should be creating layered networks. So again, so your cluster of web servers might be here, your cluster of SQL servers is over here, and your cluster of file servers is down here. They connect, there's routers and firewalls and stuff in between, so that only, certain systems are able to communicate with the other systems, right? The idea being is if your Zimbabwean ninja hacker is able to compromise this part of the network, they will only be able to compromise this part of the network. They will not easily be able to get into the other parts of your network. On top of that, though, each box, virtual machine or physical machine, there's software firewalls. And so in the software firewall, you can configure exactly who is able to communicate to this server on what particular port, right? So port 80 is fully open. Port 22 is only open, let's say, to one specific IP address. So 192.168.1.50 is able to get into port 22. That's SSH. Nobody else is. And that's basically what you can do with UFW, is you can go through and you can do these configurations, again, to add yet another layer of security, right? If the Zimbabwean hacker gets in here, they should be locked into only that. But if somehow they're able to bypass, and get into this network, if you have the software firewalls, hopefully they will add another layer of defense. The idea, again, when you're thinking about cybersecurity, is the core concept is expect a large chunk of your cybersecurity to outright fail. Now don't be lazy. Build it as if all of it's perfect, but then expect half of it to fail. And if half of it failed, would your system still be secure? And so that's one of the things you can do with UFW. We're not going to deal with UFW today because it gets to be a disaster. Again, it's Linux configurations, and if you don't do it right, it'll make you lose your damn mind. But this is the other thing to be careful about, is you can check on the status of UFW. So sudo UFW status. Again, if you build a web server, if you build a web app with Bottle or whatever, and it keeps failing, one of the things just to take a look at is sudo UFW status and verify that your firewall is inactive. If it shows that your firewall is active, again, if port 80 is blocked, it doesn't matter how good your code is, nobody's going to be able to access your web app. And there we go. There we go. I will restart chat again. Hopefully the hackers have gone away. The Zimbabwean ninja hackers are out. Hopefully they couldn't handle 2 hours of Linux. Yeah, so any questions? That's the class. That's about all I've got to say for this. Do we have any questions? Thank you. Yep. No questions? Cool. Fair enough. You ever get to that point? I don't know if you do classes or whatever. You just kind of get to that point where you're like, I'm done. I'm done. Can I go home? Oh, we got it, Christopher. Oh, what's up, Chris?
What makes Linux a much more stable operating system versus, let's say, like Windows, which has a much higher income and, VOS versus, let's say, like Mac, where, Mac is more stable than Windows?
Basically, it's designed because way back in Windows 95, Bill Gates or somebody came up with the idea of something called the registry. Oh. And so basically the registry in Windows was a great idea that's just god-awful in implementation. What the registry is, it's literally a database that's supposed to contain all the important configurations for your computer. So when things are supposed to start, when your computer boots, what's supposed to start up when it boots. When your computer shuts down, what's supposed to shut down when it shuts down. Where temporary files are supposed to be stored. There's thousands of configurations in the damn registry. The problem is trying to secure the registry is just a miserable disaster. Again, I've talked about that before with operational security, where security through obscurity is a horrible idea that kind of sort of works. If people don't know what to attack, it makes attacking more difficult. If you have a big thing called the registry that millions of computers are using, that's a really good target. And so like back in the Windows XP Service Pack 1 era, literally the registry was so insecure, you could go to a website and a website could drop registry edits into your system without you even being notified. Like, it was a fucking disaster. Anyways, they've done it better. It's been 20 years. They're better, still not great. And so basically the issue that you just run into with Windows is just, its design principles, how the damn thing is designed, is just a pretty poor design, just from a just factual standpoint. And then the other thing too is that it's a much more open system, so you can do anything you want with Windows. Right? If you want to turn your Windows computer into a telephone server, into a VoIP server, whatever you want to do with your Windows computer, you basically can do it. There's very few hard-coded limitations to what Microsoft doesn't allow you to do. The good part about that is then you can do anything you want with that. The bad part about it is if a hacker, again, with escalated privileges, is able to run commands in your system, it can just turn everything into a disaster. Like, think about that again, back when I was in the corporate world, we were running NT 4.0. And so IP address renewal, you could only renew your address at that point if you were an administrator on the system. So we had salespeople, just normal salespeople that went out in the field and traveled all over the country. And so when they went to our different offices and they plugged into the network, sometimes the release renew of the IP address just didn't fire properly. So they needed the ability to be able to renew and release their IP addresses. No big deal. So we made them local administrators on the computers, and then they were able to renew and release their IP addresses and install Napster. And, oh God, users, and that's like the issue that you run into, is like you give them permission to do one thing and then they start doing a whole bunch of wacky other stuff. And so that's the thing, is it's just Windows is by default open. It's by default has a registry and some other stuff. And so it's just more vulnerable. And so that's where if you look at like Mac is just a more locked down system in general. And then again, if you look at like the devices, the mobile devices nowadays, almost the only way to install anything is to go through those app stores, and that adds more and more and more layers of security. So that's basically why Windows is an utter disaster, to be honest with you. Yep.
Thank you very much. I appreciate that.
Yeah. Yep. Yeah. Windows is. I used to be a Windows fanboy. Again, I was. Again, you all. Outlook. I remember when the new versions of Outlook would come out, I was a clappy little boy. That was a long time ago. Yeah, Windows just got bad. Like Mac, like Linux didn't used to be that great. Again, you go back 15 years ago, it had its quirks. And then Mac, I mean, people forget what Mac was like in 2010. 2010 Macs were garbage. They were trash until they got solid state drives. These guys actually. These are the ones that actually converted me to Mac. And so 2013, yeah. And that's the thing, PCIe solid state drives on here, Mac could actually function at a different speed, at a good speed. And yeah, this changed me over from Windows back then. But yeah. Okay. Anybody else? Mute you again. Cool. All right. Is it harder to install Linux on a Windows computer? But it's not Windows computers. There's hardware. So there's Intel hardware and ARM hardware, and so on and so forth. Basically, all you need, if you're going to install Linux, easy way to install Linux, is you need an Intel system. So again, you'll notice I keep saying Intel. So this is Intel. I don't want to move it because I don't want to screw something up. That is ARM. So I have an M2 Pro ARM system right here. So you can't install Linux onto that, or you can. It's a janky piece of crap. You don't want to do it. So what you need is an Intel processor. So the Intel Max will do it. Or again, basically, I would argue any computer that was more or less built after 2010. So like you can't use. You probably can't use Google Netbooks or Google Chromebooks. Those probably won't work. But anything that you would consider is kind of like a normal laptop, like a normal laptop, a normal desktop, you should be able to install Linux. The main thing is you are going to need to get into the boot menu. So it used to be called BIOS. It's now called UEFI. And there will be a boot option. And so somehow you get into it. Somehow. I used to just run my hand over the keyboard to find out what command to do it, but you should get a boot option that pops up, and that boot option will say basically what do you want to boot off of, and you already need your flash drive in the computer, and then you tell it boot off the flash drive. When it boots off the flash drive, It'll go through, you'll get this little thing, it'll say, what do you want to do? Say, try install Ubuntu, you click try install Ubuntu, then you do install Ubuntu, and then you just follow the process through. So basically, more or less, anything other than an M series Apple computer or like Chromebooks, anything else, you should be able to install Linux on. And it's not really hard, it's like, it's just, like installing Linux is not, basically it's like one of those things. If you can access the boot configuration, you're fine. If you can't access the boot configuration, you're screwed. Like installing Linux, there's just no, you just do. Anyways, there you go. Cool. Good deal. Good deal. So yeah, okay. If there's no more questions, I am about cooked, I gotta say. About cooked. So yeah, do remember the website is now up and running. So Silicon Dojo. If you go to silicondojo.com, you can see the classes that we're going to be holding. If you click on the RSVP, that'll just bounce you over to the different meetups. So anyways, so we got the introduction. So here in Asheville, we have Introduction to Python next week. I didn't set those up right. Anyways, we have web app architecture here next Wednesday. And then we have form validation and sanitization with JavaScript and Python. And that will be next Friday. And so basically the idea is I try to do 2 online classes per week. So generally now it's Wednesday and Friday. Also trying to do one in-person class here in Asheville. And then again, we'll do Raleigh or whatever when the time comes. And again, if you find this valuable, and you got a couple of dollars, there is DonorBox. There is DonorBox. It is saying it exists. It exists. So there are no more questions. I'm gonna go. No more questions? Oops, Chris. What's up?
I have one more question.
Yep.
I don't mean to be a pain in the butt, but will you do an online class of the same class that you did?
Oh, the in-person. So basically what I'm trying to do here with Silicon Dojo is I'm actually trying to create a system. Like, again, I can do these classes damn near all day. I could do 3 classes a day if I had the material. I don't have the material. So basically what I'm doing through all of this is we're slowly building out a curriculum. My goal is a year from now, it's going to be somewhere between 50 to 100 classes, and I can just pull out the documentation and roll with it. So with a lot of these classes, like the Introduction to Python, so I've already done Introduction to Python a couple of times. Like if you go to the YouTube channel, like we did Introduction to Python, I don't know, a little while ago. Like I said, we got all these videos up here. So a lot of that we won't do again simply because it already exists here. So yeah, I don't know. Where it is. We got CSS, we got lists. Yeah, so we have a Python introduction from July 3rd. So yeah, it's basically like what's in person is going to be it's going to be like a newer version, because I have done it before, of basically what we've already done here online. Yep. And then also with the online thing, at some point, again, once I've got enough classes, we are going to start a process, because again, right now it's helter-skelter to high hell and back. It is. So one of my goals is, again, maybe on the 6-month mark from here, once I have the classes, start putting them into a much better order, and then actually start running these online classes. So it might be like every Monday. Like, so right now it's Wednesday and Friday are new classes. So what it might turn into is Monday and Wednesday are old classes that I just go through, and then Friday will be the new class, something along those lines. But that's coming.
Cool.
Yeah. Cool. All right. Is the in-person classes can be in YouTube too from Oaken? Yeah, not really. Bringing a camera into the in-person environment. One of the things that, again, something to be thinking about with technology is how do people actually interact with it? I find cameras are more doors than windows. Like people think like the camera, well, I'm just going to set up a camera and then I can share this to the world. Again, I'm in front. It's like you do something for a while. I've been doing this since 2009. I've been doing this like 16 years or something. There's something, camera. This is a two-way street. Things come out of them. Things come out of these damn things. And I don't really want that in the in-person environment. Again, when I did fireside chats, when you're doing like larger public events, I don't really mind cameras there. But like with classrooms, there's something about you put a camera into an in-person classroom, and it changes the dynamic. It just changes things. So yeah, no. So generally, probably not. I mean, I'm never going to say never because you know me. I might change my mind, but probably not. HIPAA. Well, it wouldn't be HIPAA. It's health insurance. Unless somebody has a heart attack during the class, it wouldn't be HIPAA. Anyways, cool. No more questions. See y'all. It's Friday. Jesus, Friday. See y'all next week.